All right, week 29, Thursday. Don't forget to just cross these out. These are supposed to be number lines that did not make it through the converting channels of computer to paper. So to draw the box plot on number one, we're just going to look at our minimum and our maximum. So a 0 to 10 number line would fit that data nicely. So I'm just going to draw my number line. And I'm going to mark 0 and 10. Halfway, I'll mark my 5. And then I'll just split that up into pieces to do my 1, 2, 3, and 4, as well as here's my 6, 7, 8, and 9. Just try and make it as even as possible. And we'll put a dot at 3 and a dot at 9. For whiskers. Remember, it's a box and whisker plot too. And quartile 1's at 4.5. Quartile 2 is at 6. And quartile 3 is at 8. Then we box them in and draw our lines connecting our dots, and we're done. And we can't do number 2 at all. So you can just skip it, but at least recognize that this line right there, that is quartile 3. Whatever number it would be, who knows? Because the number line didn't transfer over. All right, so remember that with mean absolute deviation, or MAD, what we're looking for is how far, what is the distance between each original point of data and the mean. And then we make a new list and we find the mean of that. So the deviations of the data is how far each number deviates from the center point or the mean. And then we take the average of that. So I'm going to ask the question, how far is 3 from 9? 6. How far is 3 from 9? 6. How far is 11 from 9? 2. How far is 12 from 9? 3. And how far is 16 from 9? 7. So now we average those out. So we've got 12 plus 5 plus 7, which is 12 plus 12, which is 24. So we're going to take 24, and we're going to divide that by 5. 5 goes into 24 4 times, with a remaining 4 out of 5, or 0.8. So the mean absolute deviation equals 4.8. Yes, that is a 4. Now, it looks like an even worse 4, but you get the idea. So some more practice with mean. We're just going to add up all these numbers. You can add them up in any way you like. I just go 2 at a time, and then I narrow those down. 3 plus 4 is 7, so now I have 16 and 15, which is going to be 31, and a 7, which is going to be 38. So now we're going to do 38 divided by how many numbers there are. 1, 2, 3, 4, 5, 6 numbers. And so 3 goes into 38 6 times, which is going to leave us 2 sixths, or 1/3. And it's 2 6 because there's 2 leftovers out of groups of 6. So 6 1/3 is our mean. And if we did that as a decimal, remember 6 1/3 is like 6.33333333333 forever. And that's what we would get. So this question asks 12 times what is 72? Well, 72 divided by 12 will give us the answer, because I would cancel out the 12 and leave us B. And 72 divided by 12 is 6. So B equals 6. So if you want to break this down, you can. I'll just explain what I wrote to find the area of a trapezoid, is that I draw lines to create right triangles, and I showed that in a picture here with my 90-degree angles. So I have 2 right triangles and a rectangle, and then I find the area of those figures and add them up to find the total area of the trapezoid. So if this is figure T, the trapezoid, and I draw in my right triangles from each pinnacle, or each vertice down, I create figure A, B, and C. Right triangle A, rectangle B, right triangle C. And if I take the area of A and add it to the area of B and add it to the area of C, I will get my area of figure T, or the total.